group student consists of 4 members. I'm Choi, Lê Hoàng Gia Khánh, Nhân Minh Nguyên, and Nguyễn Thành Lam. Today we are going to talk about the removal of antibiotics in aqueous solution by using iron modified fly ash. As a common knowledge, antibiotics in wastewater have caused many serious problems to the environment, animal, and human. Thus, treating these compounds is an issue for the whole society. In order to treat them, the advanced oxidation process using hydroxyl radical as a strong and non-selective oxidant are known to be the most suitable techniques and the only solution available in some cases. Among all these processes, the classical Fenton reaction using Fa2 plus iron and hydrogen peroxide to create the hydroxyl radical which is the most common one. However, this process will have some of its drawbacks, such as large amount of waste, catalyst retrieval difficulty, and last but not least, high cost. In order to overcome all of these drawbacks, our team has studied a pollutant called fly ash, which is a byproduct from burning fossil fuel. Fly ash contains a high amount of iron. The amount of iron in fly ash takes up to 8% of this pollutant mass.
So in this project, 3 clear objectives have been set. First is to modify and create catalysts from fly ash that can effectively treat antibiotics and other persistent organic pollutants. Secondly, reduce the cost of the pollutant treatment process. And lastly, contribute to tackling the environmental problems regarding fly ash.
For this purposes, we designed the experiment as follows. 1. Modification of fly ash. 10 gram fly ash into a 5 gram added surface was added into 20 ml water. The mixture then was mixed and heated to 100 degrees C for removing water. The obtained solid was processed at 600 degrees C for 4 hours to obtain the catalyst, iron and fly ash, which will be used for degradation of antibiotic and other organic pollutant. 2. Degradation of pollutant. First, the wastewater contained pollutant was adjusted pH. Then, the mixture of catalyst and hydrogen peroxide was added into the wastewater during the mixing to start the treatment process. At the suitable time, the wastewater was sampled for analysis and determination of treatment efficiency.
Okay, now we're moving to the result and discussion section. By using the EDS spectra, we confirm that fly ash was successfully modified by the impregnation process as the iron 3 oxide content increased from 8.5% to approximately 31%. In this project, we also investigated some key operation parameters such as pH, catalyst dose, the hydrogen peroxide concentration, and their effects on the treatment efficiency, and we have obtained the following results. Firstly, pH has a huge impact on the success of the treatment. As we can see, with the pH value ranging from 2 to 3, the treatment was much more efficient than with the pH value ranging from 4 to 5. So to be concluded, the optimal pH value was determined to be 3, and this value was used for the next experiments. Secondly, the effect of catalyst dose was examined with the value ranging from 0.6 gram per liter to 1.4 gram per liter. The experiment indicated that when the catalytic dose increased from 0.6 to 1.2 gram per liter. The process efficient also increase and reach its maximum. However, when the value went even higher to 1.4 gram per liter, the productivity began to drop. Therefore, the ideal catalytic dose for this experiment was determined to be 1.2 gram per liter. The experiment also showed that hydrogen peroxide concentration of 0.5 milliliter per liter was the most suitable because at this value, the efficiency optimized in the shortest time.
To investigate the potential application of our catalyst, similar process will apply with organic waste such as dye, pesticides, textile water, and the results are obtained with high efficiency from approximately 85% to nearly 100%. The stability and recyclability of iron modified fly ash catalyst was evaluated by recycling and reusing the catalyst over 5 consecutive cycles. After each run, the catalyst was separated from the solution by filtration and then dried for the next degradation experiment. The experimental results indicate that the catalyst can be separated and reused many times.
So, as conclusions, we have successfully produced heterogeneous Fenton catalyst from fly ash by a simple impregnation with iron-free solvent. Key numbers were investigated and optimized using MODDE software under the optimized condition, including pH 3. The catalyst dose and hydrogen peroxide content of 1.2 grams per liter and 0.5 milliliter per liter. The treatment efficiency of about 95% after 120 minutes. The kinetic study showed that the process had taken place easily, with low activation energy of 17 kilojoules per mole. The advanced model has good predictability. Iron modified fly ash can be effectively used to degrade many persistent organic pollutants. And lastly, treatment costs can be reduced, contributing to solving fly ash problems. So if you have any questions, please contact us.
Thank you.